Hi there, thank you for watching this video on a new feature in vRealize Network Insight 6.4 called the Databus. My name is Martijn and I will be guiding you through this awesome feature and showing you how to use it. But before I get started, be warned, this is for advanced users as it's an API programmatic driven feature and it leverages the power of all of the data that vRealize Network Insight collects and then gives them to you in a way that you can use it. Hence, it's called the Databus. So what is it? Well, vRealize Network Insight is a data lake. That's a given. There's a lot of data inside VRNI, whether it be about VMs, switches, ESXi host, NSX topologies, routers, switches, firewalls, traffic that traverses the network, and there's a lot more. And then there's also the fact that there are historical versions of all of that configuration and all of those metrics. So why the Databus? Well, mostly because all of the data is available via the public API that you can pull from. However, if there are certain data sets within VRNI that kind of require you to do constant pulling in order to get the up-to-date current information. So the Databus is a way to push that information to you instead of you having to pull it from VRNI. So what happens is that the Databus has a thing called subscribers, and a subscriber is a URL which you can define, which VRNI will then use to start sending the incoming data. So as soon as the data comes into vRealize Network Insight, it will look at the subscribers and then send it to those subscribers as well. So it's a lot quicker to get alerts and application updates that way, because those are the two messages that we are currently starting with. So anytime a new alert is generated within VRNI, so whether that be a configuration error or a operational error like packet drops or a mismatched MTU size, those alerts will be sent along with any application construct update. So if there's a new VM added to a application or even a new tier, whether that be via the manual way of defining those applications or using an application discovery method within VRNI, it will send you all of those application updates along with the entire application definition. And I will show you that in a quick demo that I've got at the end. So I've already mentioned this, but the Databus itself is more of a push mechanism where VRNI decides to push that information towards you, towards an endpoint where you can process that information, instead of the API where you have to go and connect to VRNI and then get the information that you need, which makes it a lot easier to handle large volumes of data. So what can you do with it? Well, kind of everything. So alerts is one thing where you can react on specific alerts, whether that be something like an MTU mismatch or a VLAN trunk mismatch on two switch ports. You can send those alerts to any place you want, so whether that be Slack or ServiceNow tickets, maybe even PagerDuty, Telegram, or wherever you want to send that alert to. You can filter on it, you can make sure that the right alerts get routed to the right people. Another example is reacting on firewall rule changes. So you could have the default rule within NSX, for example, set to deny. And VRNI will generate an alert when that default rule gets set to allow. So any traffic will be allowed at that point. So that's why it generates an event based on that, an alert. And that alert also gets sent via the Databus. So if you want to make sure that your default rule is always set to deny, you can use that alert and then go back to NSX and actually just revert that change. One of the coolest features or use cases that I've seen so far is updating the configuration management databases based off of the application updates from VRNI. So vRealize Network Insight is used for application discovery. It looks at the network traffic within the network itself and then formulates application boundaries based off of that network traffic. And then forms these application constructs from VMs, physical IP addresses or Kubernetes services. So it knows better what an application construct is than the CMDB typically does know. So with this feature, we can react on the application updates and then update the actual CMDB based on what vRealize has discovered from the network. So always up-to-date documentation. We will have a very rich example repository where you can find example scripts on how to do these examples, which you can find in the blog post that is attached to this video. To use the databus, you need to set up a subscriber. So that subscriber is an HTTP endpoint. It could be HTTP or HTTPS. And it could be like a regular web server, or you could use something like the VMware Event Broker appliance or Prometheus for the incoming alerts. You just need to give it a specific URL where you want the application updates coming in or the alerts coming in. You can register multiple of these subscribers, so there's just a limit of 25 of these subscribers that you can enable. So you can have the alerts going to multiple places if you'd like. So let's have a look on how that actually looks, and I'm going to show you that in a quick demo. In this demo, I'll show you how to create a Databus subscriber, and I'm going to start with the API documentation that's built in. And over here you can search for Databus and then get all of the endpoints that you need to manage these subscribers. And one of them is the post, so we're going to create a subscriber. I'm going to actually do that a little bit simpler by using Power vRealize, and I've already authenticated here. I've connected to the vRealize server, and I'm just going to look at the available subscribers as it is right now. So there are already 2 enabled, as you can see, 1 for applications and 1 for problems. And I'm going to add 1. And for that, I'm going to use this free service called bScepter, which will give me the exact output of what the databus is sending itself. So I'm going to use this URL to create a new vRealize databus subscriber. I'm going to give it the message group for applications, because I want to get application updates, and then give it a URL. And this will create the subscriber, and I can verify that by getting all of the database subscribers again. And you can see right there it's been added. So give it a few minutes and an application update. So right here I'm going to update an application that Flow-based application discovery has discovered that there's a new VM. And then I'm going to go back to bScepter, and there's a new post here that you can see with the body of the Databus output. So there's one update to an application. You can see the name, you can see the modified by, who created it, and the entire makeup of the tier. But just to make that a little bit more readable, I'm going to use the JSON prettifier. Just paste it, make it pretty, and it's a little bit more readable. So we have the entire makeup of the application as it is after the update. So we have the tiers, the name of the tiers, and also the members of those tiers. So those could be VMs, IP addresses, or Kubernetes services. But in this case, we just have VMs, as you can see. But it also includes like the IP address of those VMs, the vCenter ID, so anything that you would need in order to do kind of an action on these updates. So now I'm going to go back and add another database subscriber for the problem. So I want to see alerts within bScepter as well. To change the message group, that'll add it, and I can verify that again by doing the get vRealize database subscriber, and there we go. So now give it a minute or so before some alerts have been generated, and then I can refresh bScepter and look at the post output, and there it is another different output, which is the alerts that come in. So go ahead and going back to the JSON prettifier again, just to make it a little bit more readable, and you can see we've got an open alert with a specific name. So this is a unique name within vRealize to identify it. And then the related entities are the objects within vRealize that it's attached to. Severity, tags, even recommendations on how to fix it are also there. You can also look at the headers that this API call is sending. So the database is sending a tenant ID and a stream ID to more identify those things. And then lastly, I just want to clean up after myself. So I'm going to remove these database subscribers again so I don't overload this service. And the only thing that I need to do is, wait 1 second, the other way around. So I need to get all of the Databus subscribers and then filter on the URL. The URL equals to this. And then all I need to do is remove VRNI Databus subscriber over here. And it'll remove all of the subscribers. All right, so this was a quick look on how to set up the Databus subscribers, how to interpret those outputs, and then start using them. Thank you for watching.